G'day and welcome to the first video on completing the square. These are factorising quadratic trinomials, but these ones cannot be factorised through any other method that we've looked at before. You can't use the difference of two squares or the cross method or splitting the middle term. You actually need to use something else. And this one can be a little bit tricky because we're actually kind of making the question look like something that we want to. So we're manipulating it and then I guess sorting it all out at the end. So can you follow the process of this one just a couple of times, and then you might start to understand why we do the process a little bit later. Okay, so here I've got x squared plus 6x plus 1. I try the cross method, but it's not going to work. Okay, I try the splitting the term method, it's not going to work. But it still can be factorised. I'm going to just do this. I'm going to say it's x squared plus 6x, and I'm going to put this plus 1 out the back here. I'm just going to leave it out there for the moment. Now what I'm going to do is I'm going to, I guess, invent a question that I want to answer and then answer the actual question a little bit later. Okay, so I've got x squared plus 6x. I want to put a number in here to make it a nice square, in fact a perfect square. So what I'm going to do is I'm actually going to get this number here, this 6, and I'm going to divide this number here by 2, so I'll do it over here. 6 divided by 2, which is 3, and I'm actually going to square this term. So I'm going to square that 6 divided by 2, and I'm going to square that 3 there. So that becomes 9. The reason I do this is because now when I do this, x squared plus 6x plus 9, it seems a bit abstract, you know, why the heck would I do that? But remembering back to when we do, you know, if I use the cross method on this, I'm going to get x plus 3 all squared. Remembering when we actually expand this one, we get x squared plus 2 times 3 times x plus 3 squared. That's expanding that one, you get this. If I'm going to get 2 times 3x, which is, you know, 2 times that, then it only makes sense that if I'm actually trying to find out what this number is at the back, this 9 here, I'm actually going to get half of this term here, because then that will give me these two things here, the 3 and the x. I hope that makes sense. If it didn't make sense, you can just follow this pattern over here where we divide that middle term by 2 and then square it. Okay, so, but the reality is I can't just kind of add plus 9 into the question. It's not allowed, it doesn't make sense unless I also subtract it as well. Now that seems a bit silly because some people will argue, well, why don't we just do 9 minus 9 and then I'll get back to 0. Now I could do that, but then I'd just get back to where I started and that wouldn't be helpful at all. So what I've actually done is I've artificially added in 9 into the question so that I can get it down to this perfect square, x plus 3. Now if I artificially add in plus 9, I also have to subtract 9 as well. But this means that I can actually factorise this thing. So minus 9 plus 1 ends up being minus 8. And then I get, I can do the difference of 2 squares on this one now. Okay, and I end up getting x plus 3 plus the square root of 8 and x plus 3 minus the square root of 8. Hopefully I haven't made too many jumps with that one so that you can understand what's going on. Okay, so it was a process of halving this middle term and squaring that middle term. Adding it in, subtracting it, and I get the answer. Okay, let's have a go at this one over here. X squared plus 8x minus 2. Again, I'm going to put that minus 2 right at the back. The thing, I need to add and subtract a number in here. And the number is related to this 8x here. In fact, it's going to be half that number. So I'm going to add 8 divided by 2 squared and subtract 8 divided by 2 squared. Some people will ask, why don't I just use 4? And I mean, that's a valid point. I guess the only reason I do this is later on you might deal with fractions and it gets a little bit harder, so it's easy to see with 8 over 2. And so I get x squared plus 8x plus 4 squared, which is 16, minus 16 minus 2. That always comes down to x plus 4 squared minus 18. Now just a little hint, a little tip for you. Whatever this number here is here in this bracket, so 8 divided by 2, which is 4, that will be the same number as down here in this bracket. Okay, so that number turns into this number here. But you can just use the cross method on these things here. There's no reason that that won't work. So in the end I get x plus 4 plus the square root of 18 and x plus 4 minus the square root of 18. Now for some of you, you might have seen me do something crazy with this root 18, but for this semester I'm just going to leave it as root 18. Sometimes the textbook is unhelpful because it changes the answer on that, but this is the correct answer. In the next video I'll go through example 3 and example 4, but thanks for watching this one.